Alright, ladies and gentlemen, Benjamin here. Actually, I should say fellow ham radio enthusiasts that want to make radios and modify them to do other things. So this project here I've been working on for the last few weeks, and what this eventually will be, through hell or high water, for the simple reason that I want to do it. And it's teaching me a whole lot, and therefore if you go through the same process, you're going to learn a whole lot about radios and how they work. And anyways, there's a reason you want to do that. But anyhow, this is a Motorola 6-meter max track that originally was 42 to 50 megahertz. Now what I want to do is turn this into a 6-meter beacon transmitter that will operate somewhere on the frequency range between 50.005 and 50.095, so somewhere in the beacon frequency. Now, through my trial and errors up to this point, I have been able to make it beacon. However, it's been proven to be really, really crappy. I made a video to my friends, and switching the radio back and forth between CW mode and sideband, and then turning the dial just a few hundred hertz, it sounds like a rap song. It's really funny. Anyway, using Arduino to key the radio through this black wire here that actually keys it, and then this green wires actually send a signal, a 5-volt signal to this little mess of transistors. And what this mess of transistors is doing is that this one is a NPN transistor, and it is actually turning on and off this PNP transistor. Now, the reason why I'm using a PNP transistor as a final one is because that allows me to control whatever voltage I want through it. So in this case, the circuit is requiring 9.6 volts. Well, obviously that little pissy ass Arduino IC is not going to provide me 9.6 volts at the current I need. So I just use an NPN transistor controlling a PNP transistor. And here's where I got that idea from, because honestly I didn't know how a PNP worked until this. So in this circuit here, okay, this is the transmit and receive circuit. When you key the radio, the microcontroller sends a signal to a transistor you don't see, and then what it does in this particular circuit, 9.6 volts goes in, it goes through a 270 ohm resistor, which is more or less biasing the base of this transistor. It's still sending 9 volts down that line, but no voltage is coming down this line here, the transmit line, to the amplifier. So when you key the radio, a transistor down this line actually grounds this out. It sends this to ground, so the base is grounded. It's at 0 volts potential, but it's at N, or neutral ground, and allowing 9.6 volts to pass. And so I did the same exact thing with this. Now, I've tried various different methods. I went so far as actually turning the radio on and off. I pulled this little, let's see if you can see here, sorry. No such luck. Anyway, okay. This little thing here, this little green inductor here, I went so far to pull that out, and what I wanted to do with that was actually key up the second amplifier, turn the second amplifier on and off. Well, had I read a little bit more about the schematic, you will see, maybe possibly, that this is the amplifier I was originally turning off. I had chopped the line there, and I was providing the 9.6 volts through this amplifier, turn this amplifier on and off. Well, if you follow this right here, this goes into the secondary buffer, but before it gets into that buffer, it sends out a signal. Now, where does this go? Oh, now, I didn't know this until after I looked at that, because I was trying to figure out why it's chirping like a Russian transmitter, is it goes back to the feedback circuit to the synthesizer. So every time that circuit was turning on and off, it was taking the feedback signal away from the synthesizer, so the synthesizer was continuous retuning, so that means it's going beep-bew, beep-bew. It sounded really freaking horrible. The next thing I tried was actually fooling the radio. I actually disconnected the sync lock, so that way the microprocessor always thinks that it's locked, and it's not trying to retune or send the retune command to the PLL IC, and actually just switching the TR on and off on this radio. Now, this radio is not meant to cycle at 20 words a minute CW. Whatever frequency you want to pulse that at, it was not meant to do that. So trying to pulse that on and off, it was doing the same thing. I got the same result. I was going from 0 watts RF to about 2.5. But again, because I was actually turning the VCO off on this one, this right here, this is the VCO, transmit VCO. Because I was turning that on and off, I was tuning and detuning and then retuning every time I was turning on the transmitter, the VCO. So like I said, it sounds like it sounds like an old crappy transmitter. So what I'm going to do, and oh, by the way, this is a modification I had to do to this circuit. This originally was a 60 watt radio. It is now a 2.25 watt radio. I did not want to have a 60 watt transmitter, a CW transmitter, and also there was something wrong with this board anyway, so I don't know what was wrong with it, but something was shorted, so I didn't feel like doing it. I scrapped it out. But this particular parts in here, the PA buffer transistor was still good. The PA driver was still good. And you see I bypassed that. And this right here used to be a single turn deal. Actually, I don't even know what you want to call this. This little half hump thing, inductor, was originally in there. And that had to be taken out, and then it had to install about a 5.5 turn inductor and replace the capacitors on the output circuit, or the output transformer, or the output match, I should say, of this transistor. Those were replaced with 39 picofarads, and anyways, now it's at 2.25. So what I'm going to do from this stage, although I really don't like it, is I'm just going to turn the controlled voltage, I'm going to turn this on and off. When this transistor right here, which will be the final transistor, when that is off, the radio output's about 4.6 milliwatts. When it turns on, it is, like I said, 2.23 milliwatts. I don't like that, but given the fact of this radio, without serious engineering and honestly proving my point, or just learning a whole lot about it, I'm just going to deal with the 4.5 milliwatts that comes out of that during its off cycle. So this wire right here is the 9.6 volts to transmit, which turns this transistor on, the first actually buffer amplifier. And this orange one is the control voltage. This is actually how these other radios work. The orange one is control voltage, actually controls this one here. This is actually the transistor amplifier that controls the amount of power going to the final amplifiers, and that's how you get your controlled voltage, or that is how the RF output is controlled on the VHF, and the VHF low band is through this transistor here. So I'm just going to have the Arduino turn it on and off. The current draw is 300 milliamps is what was measured. Now, of course, I had to get the output impedance matching circuit. I had to get it right because otherwise my initial tests were I had about 3/4 of a watt when it was drawing about 1/2 amp. And after you do the math, the efficiency was about 6%. Now the efficiency is at 50%. Actually, it was like 57% is what I got the efficiency up to. So now instead of drawing 12 volts at 500 milliamps with 3/4 of a watt output, it now draws 12 volts. Well, at 12 volts, it draws just right under 300 milliamps with 2.25 watts out. So anyways, I'm just going to have this turn on and off, and that's it. That'll be my CW beacon. Listen for it. It'll be on either 50.005 or somewhere else. Listen for it. KB9LFZ. Signing out.